Hello guys, welcome back to another SATs video. Now I'm here to prepare you for the 2024 paper. So I've gone back through all of the previous SATs papers. I've got a bunch of real questions, all to do with fractions. Of course, fractions is a huge chunk of preparing for the SATs, and it's really, honestly, a topic that a lot of people struggle with. So we're not even going to go through the basic stuff. I'll leave that to Hayden. Okay, I'll leave the basic arithmetic stuff to Hayden. We're going to jump straight into some problem solving questions. So let's not waste any more time. Let's get straight in, see how you get on, and I'll show you how to answer every single question correctly. So here's our first one. We're going to start off with some equivalent fraction work, okay? And what we often see in the problem solving paper of the SATs is that, yeah, it's going to ask you to find some equivalent values, in this case, fractions, but it will often give you a picture representation as well. Now, the thing is, you don't need the picture representation to solve this. You could know how to do equivalent fractions. For example, here, what's going to go in this gap underneath the numerator 9? Well, we know it's equal to 3/4. So you may well straight away see, okay, what's the link between 3 and 9? Well, to get to 9 from 3, I had to multiply by 3. And you know the rule, I'm sure, that for a fraction to be equivalent, we must do the same to the numerator as we do to the denominator. So we're going to take the 4 at the bottom and multiply that by 3. 4 times 3 is 12. We'd actually get that right. You don't even need to look at the pictures. But you know what? If you're a bit stuck or you want to make sure, the pictures are a fantastic way to do it because we can literally just count. So let's take a look here, 3/4. The 3 represents how many are shaded. We can see 1, 2, 3 parts shaded. And the denominator is always how many equal parts we see. Well, in this question anyway, you'll see what I mean later. So we have 1, 2, 3, 4 equal parts, and we have 3 shaded. So we see here this 3/4 is represented perfectly by the picture above. Same for 9/12. 1, 2, 3, 4, 5, 6, 7, 8, 9 shaded out of 3 more, so 12 in total, right there. So that's 9 out of 12. Again, over here, I'm going to show you the method of using the picture. We'll just count them up. 1, 2, 3, 4, 5, 6. Now we could keep counting, or we could notice, well, that's just going to be another 6, and that's another 6. 3 lots of 6. That's going to be 18. So 2 ways to solve this one. If you're really confident with using equivalent fractions, just use your normal method. Multiply with the top and the bottom by the same number, or divide if you're simplifying. But if you're stuck and you get pictures to help you, use them, guys. Now this one, I'm going to leave you to have a go at. Okay, so this is similar to what we've just talked about, but the picture is a little bit less helpful, and you'll see why. Have a go yourself, see if you can get an answer. Tick the fractions that represent the shaded grid. Notice this, there's an S on the end. I know this isn't a reading paper, but you need to understand that this means there's going to be more than one. How many? We don't know, so check them all. Tick the fractions that are represented by the grid. So just gave you a chance there to pause and try and work it out. The first thing to notice is this is a 10 by 10 grid. So there are 100 squares. That's going to be our denominator to start with. Very simple. And then again, we could start counting 1, 2, 3, 4. That's a bit slow. Can you notice that each column must be 10 because it's a 10 by 10 grid, so that's 10 tall. And we have 1, 2, 3, 4 columns. So 4 times 10 is 40. 40 out of 100, we can tick that straight away. But going back to what I said, there is a plural in the question. It's not fraction, it's fractions. So we need to now simplify 40 out of 100 as many different ways as possible. First thing to notice actually is 1/4. I'm going to do a whole video on fractions, decimals, and percentages as equivalents, but a little bit of a spoiler right now. This is 0.25, and that is a rule you just need to know. Now, how's that helpful? Well, we know that if a decimal is 0.25, that's 25%. Cool. How's that helpful? Well, we know if it's 25%, then it's also equivalent to 25 out of 100, which is obviously not 40 out of 100, so that doesn't work. The trick here that a lot of people fall for, they see a 4 in the denominator space, they see a 4 here, and they go, yes, it's 4. No, 1/4 is not the same as 40 out of 100. Absolutely not. However, it is the same as 4 out of 10, because if we divide 40 by 10, we get 4, and if we divide 100 by 10, we get 10. So 4 out of 10 is equivalent, and once we know 4 out of 10 is equivalent, well, 6 out of 10 is clearly different because we've still got tenths, but we have 6. So 6 out of 10 is much bigger. Can't be 6 out of 10. The only one left is 2/5. And again, if we look at the link here between 4/10 and 2/5, it is equivalent because if we divide 4 by 2, we get 2. If we divide 10 by 2 and do the same, we get 5. 2 out of 5, just sneaking on the end there. So you should have ticked 3 boxes. Well done if you did. If you didn't tick all 3, you wouldn't get all the marks for this question. You have to be super careful. Next one. Like the evolution, basically, of this kind of question. Now we have no picture prompts whatsoever. Can you fill in the gaps? Could you get these marks on a real SATs paper from 2022? I like this question because, yeah, I know there's two things to do, and there's two different things to do. It really does test you on your ability to use equivalent fractions. So how do we get from 10 to 20? Well, we multiply by 2. So simply at the top, do the same. 3 multiplied by 2, this is going to be 6 out of 20. That's something that most children can do. Most people get that right. The next one is trickier because simply, we're not multiplying. How do I go from 12 to 4? Well, we have to use our division facts, and famously, or infamously, it does not have as much of an effect on children's learning to stay in their mind. Children find learning times table facts easier than learning division facts. So how can we know what to divide by here? Well, you might know it's 3, and then at the bottom you do 15 divided by 3 and you end up with 5. But I'm going to show you a little hint here. If you're not confident with your division facts, just still use multiplication, it's fine. Let's go backwards. 4 multiplied by what is 12? That might much more simply to you be 3. And then straight away we know, well, the inverse is just divide, so it's still going to be 3. That could help you. Equally, you might then look at the bottom box and say, okay, box times 3 must equal 15. And again, children find this more easy than trying to just pluck out a division fact out of thin air. Again, the answer is 5, so well done if you got both of those. Okay, kind of, again, evolving on from the equivalent fractions. Tick the fractions less than 5/8. We still need to use our ability to change fractions and change the denominator and keep things equal, but it's slightly different now. So again, I'm going to let you have a go yourself. Tick the fractions, plural, doesn't say how many, but we know it's probably going to be more than one, that are less than 5/8. Have a go. I'll go through it after. Okay, so for this question type, every single time we're going to be coming back to 5/8, okay? So I'm comparing 1/2 and 5/8. Well, let's change this to 8s. 2 times what is 8? It's times by 4. So times the top by 4, we get 4/8. Is 4/8 less than 5/8? Yes, it is. Next one, 2/8. That's simple. I don't need to do any converting because it's already an 8. 2/8 is obviously less than having 5 of them. So we tick that one. Next one is 3/4. Again, let's change it to 8s. 4 times 2 is 8. So multiply the top by 2, we get 6. Is 6/8 less than 5/8? No, leave it blank. Next one, 7/16. Aha. Okay, well, do you know what I'm going to do this time? Instead of trying to half 16 and then half 7, which gives me it's an odd number 7, so I'm going to get a decimal. That's really confusing. No, I'm just going to change 5/8 to 16ths this time. So 8 times 2 is 16. Do the same to the top, and we get 10/16. Is 7/16 less than 10/16? Yes. You may have also noticed that 7/16 is less than a half, because 8/16 would be a half. You might have those shortcuts. Use them. Use them honestly. I'm showing you the way to write this down and work it out. 24 out of 32. Again, I'm going to take my 8s. I'm going to change that into 32 because I know 32 is in the 8 times table. 4 times 8 is 32. Do the same to the top. I get 20. Is 24 less than 20? No. Leave it blank. That is the best way to actually work out this question. Change the fractions so they're equivalent, and then change it so the denominators are the same. It's really easy to compare them then. So here's another kind of, I'd say comparing, we put comparing and ordering in the same kind of category. Can you compare and order these fractions? Use the technique I just told you, get all the denominators to be the same, or you might have an even quicker way of doing this one. I'll leave it to you and I'll show you both after. What do you think? Now, we could look at 3, 6, 4, and 2 and find a common multiple. What's the lowest common multiple that goes into all of these? And the answer would be 12. 12 is in the 2 times table, the 4 times table, the 6 times table, and the 3 times table. 3 times 4, so that's 4 12s. 6 times 2, so that's 2 12s. 4 times 3, so that's 3 12s. And 2 times 6, so that's 6 12s. Now we know, obviously, the biggest one is 1/2. And we could go 6 12s because here we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 jumps. Now it's really easy. 2 12s would be 1/6. 3 12s we know is 1/4, because we've just done the equivalents. 4 12s would be 1/3, and this would be 1/2. Cool. If you did that method, you got the answer right. Well done. But you know a quicker way of doing it? You can actually compare fractions. I'm going to cross this out. Look at that. Beautiful crossing out. And we can actually compare fractions when the numerators are the same. All of these numerators are 1. So we can simply look at the denominators now and figure out which parts would be bigger. Well, 1/2 is a whole split into only 2 parts. So imagine a pizza split into 2 parts. 1/2 is this big chunk here. Now let's take the same pizza and split it into 4 parts or 1/4. Now look, the part gets smaller. So the larger the denominator, the smaller each part will be. So we know 1/2 is actually the biggest, and we could whack 1/2 into the furthest closest up to 1. Then I know 1/4 and 1/3. Well, what's going to be bigger out of those two? It's going to be 1/3. So I can put 1/3 in the next one, because like I said, the bigger the denominator, the smaller the fraction. That means 1/4 comes next and 1/6. Even though 6 is the biggest number, as a denominator, it would give us the smallest part. So we could order them like that and just put them straight into the number line. Lots of ways to answer lots of these questions, guys. Whatever suits you best. I'm going to show you all the methods I can think of. You might have more. That's fantastic. This is my favorite ordering question. Now, do you know why? Because we can use what we just talked about. We can find a common multiple, change the denominators, then compare them. We need the denominators to be the same, right? This is the ultimate problem-solving question, because there was one time a child in year 6 saw this question, just looked at it for about 5 seconds, and they said, yeah, okay, I've ordered it, and they got it right. So, okay, can you work it out, and how did you work it out? Did you manage to work it out without doing any written method, or did you have to use a written method? Both are okay. Have a go at this question. Write these fractions starting with the smallest. Okay, so here's the really cool method. We could change them all into 20ths. I'm not going to do that because I've just shown you that method, and you could use equivalent fraction knowledge. That's fine, but we're not going to do that. Let's just take a look at them. Straight away, I know which one's the biggest. So just look at those fractions. Can you tell me which one's the biggest straight away? It's 6/5. Now, the answer isn't because it says 6. That's more than 3. Okay, so you could have fluked the answer there. The answer is simply, this is an improper fraction. This is more than 1 whole. 5/5 would be the whole. 6/5 is more than 1 whole. The others are not improper fractions. They're smaller. So now we know this is the biggest. We simply have to look at these two fractions and think, okay, which one's the biggest out of these two? Well, guess what? The numerators are the same. We've got 3 of each. So all we need to do is look at the denominator. What would be bigger, a 1/4 or a 1/5? And we know a 1/4 is bigger based on what I've just told you. Imagine a piece of cake cut between 4 people and a piece of a cake cut between 5 people. The 4 people are going to get more cake, aren't they? So 1/4s are bigger than 1/5s. Therefore, 3/4 is obviously bigger than 3/5. I've just worked it out just by talking it through and using logic. That is a way to answer this question in 10 seconds. So if you manage to understand fractions that well, you can answer some of these really quickly. Okay, how about this then? We just talked about improper fractions. Circle the improper fraction that is equivalent to 2 wholes and 3/8. I'm going to let you have a go yourself. Whatever you think, go for it. I'll tell you about the tricks, and then I'll tell you how to work it out. Now, people who got the answer wrong, most often on this paper, put 23 out of 8. Do you know why? Because they see a 2, they see a 3, and they see an 8. And they go, yeah, 23 out of 8. No. We need 2 wholes. I like to draw mixed numbers. A mixed number, by the way, is any number that has a whole number, or an integer, as we'd call it, in this case a 2, and a fraction next to it. That's why it's called mixed. It has 2 types of numbers, an integer and a fraction. In this case, 2 is the integer, 3/8 is the fraction. Together it makes 2 and 3/8, which is a mixed number. So I like to draw 2 holes in. I do bars as my holes. And then I think, okay, I've got 3/8 left over, so I'm going to have to draw another hole underneath, but I'm going to have to split it into 8s. So let's just do that right now nice and neatly. That's 4 parts. I need 8, so let's split them in half again. Cool. So here are my 3/8. 1, 2, 3. Nice. I just want to count how many 8s there are then in total, counting these 2 holes. So do you know what I have to do to them? I'm going to split them into 8s as well. Simple as that. Now, I'm going to show you a really quick way to do this afterwards, but this is a very pictorial way. We have 8 8s in this hole. We need all of it. We have 8 8s in this hole. We need all of it. So that's 16 so far. We have another 3 down here. That's 19 8s. That's a very pictorial way of me proving to you that that's why it's 19 8s. We can't argue with that. The denominator is 8, so we need 8 parts in each hole. 8 plus 8 is 16, so there are 16 8s in 2 holes, plus the 3/8 left over. That gives us 19 8s. Cool. Here's a really quick method to do it if you want just a kind of thing to remember, if you understand that. Take the integer 2, multiply it by the denominator. So 2 times 8, that gives us 16. Add on the 3, it's 19. That's all you need to do. So for example, down here, if we had 4 and let's say 3/7, Okay, what's the improper fraction for that? Well, do 4 times 7, add 3. That's how many sevenths there are. 4 times 7 is 28, add 3. This is the same as 31 over 7. So there's your method, guys. Really quick way. Multiply the integer by the denominator, then add on what's left with the numerator. That's exactly what I just did here, by the way. So I've proven it works. Why not have a quick method? Why not? I love this question. I'm not going to say anything because you might know how to do fraction of amount. I know how to do fraction of amount. I could do 1/5 of 22. Is that what this question's asking? This tricked a lot of people. Can you avoid the trick? One-fifth of a number is 22. This is the answer. Again, you might think, oh, Dylan, why are you drawing it out? Because you know what? It helps me and I can prove stuff then. 1/5 of a number is 22. So here are my fifths in the whole amount. I've got 5 fifths in a whole, so I draw 5 parts. 1/5, which is one of these boxes, is 22. Well, I know that fifths for fractions are going to be equal parts. So there's going to be 22 in each box. This means I can really easily work out the number. What is the number? Well, it's 5 lots of 22. I'm going to write it like this. 2 times 5 is 10. 2 times 5 is 10. 110. Simple as that. The trick here would be you spend all your time trying to work out 1/5 of 22. You go into decimal numbers. It's a nightmare. Don't do that. You have to read the question carefully. This is why on a problem-solving paper for the SATs, I say draw all over it. You're allowed to draw on the question paper as much as you want. Do all your working out. Draw bars, draw methods. It's going to help you guys, I promise. Let's take a look at this question then from the 2018 paper. This one says show your method. That usually means there are 2 marks available. If there are 2 marks available on a question in the SATs, you have to do at least 2 things. Have a go at answering it. I'm not going to give you any help. A book has 276 pages. Amina has read 1/3 of the book. How many pages are left? The only thing I'll say to help you, the reason things are in bold is to bring your attention to it. So there's a reason that's in bold. Have a go. Okay, so lots of children look at this. They go, cool, 1/3 of the book, those 276 pages, 1/3 of 276. Let's divide 276 by 3 using the bust-up method. 3's into 2 don't go. 3's into 27 are 9. 3's into 6 are 2. 92, Bob's your uncle. Put it down. No! You're going to get 0 marks if you do that. You might say, well, it's 2 marks. I've done one thing. I'll get 1 mark, right? Wrong. To get 1 mark on a 2-mark question, you have to do all of the method, every single step, but just make a maths error. If you stopped here, you'd get nothing because the answer, the question says how many pages are left. She's read 92. That's 1/3. So 2/3 are left. This is just 1/3. So now we need to either do 276 take away 92 to figure out the difference, what's left, or you can take 92, which we know is 1/3, and we can multiply it by 2 because that will give us 2/3. The answer is 184. There you get 2 marks. What have I done wrong? I didn't show my working out. This is fine, but if you wrote down 185 by accident, or your 8 looks like a 0, you're going to get 0 marks from the marker. What you should do here is just do 92 times 2. Just write it out. You're thinking, what a waste of time. No, because if you do a misstep or write something incorrectly, you're still going to get a mark. Show your working. Oh, I love this question. A cinema sells tickets at 3 different prices. 1/20th of the tickets are price A, 3/5 of the ticket are price B, and the rest are price C. What fraction are price C? The only thing I'm going to say to you here is, look at those denominators, guys. Have a go at this question. What's left over? See what you can do. Now, I would always say to people when we're using fractions, trying to add them together, trying to compare them, trying to do anything between 2 fractions like this, when it's adding and subtracting and finding the whole, make the denominators the same. So we have 1/20th. That can stay because 20 is the largest number. We can change fifths into 20ths. So let's say 3/5 down here is equivalent to how many 20ths? Well, how many 5s are in 20? That's times it by 4. Do the same to the top. We're going to get 12 out of 20. Now we can work this question out. 12 20ths are price B. 1/20th are price A. So altogether, 13 20ths are price A or B. What are the rest of the tickets? Well, we need to have an answer that equals 20 out of 20. Okay? Because we need to have all of the tickets. So how can we make 20 out of 20? We've already got 13. 20 out of 20, by the way, is 1 whole, but we want it as a fraction, remember, because we need to make up to 20. 13 plus what equals 20. It's a simple question, and that's honestly like a year 1 question. Your number bonds to 20. It's a 7, so 7/20ths are left over. The key to this question, make the denominators the same. Guys, I can't stress it enough. If the denominators are different and you're adding or subtracting the fraction, or you're comparing the fraction, change it so the denominators are the same. I promise you, it'll be really useful. This question is very similar to the last question, so I'm going to give you no help. It looks very different, but the question is actually very similar. Have a go for me. So hopefully you can see in this picture how it's very similar. Imagine this was ticket price A, ticket price B, and we're trying to find out ticket price C. It's pretty much the last question, but this is how the SATs paper can show you the same kind of methodical way of working something out, the same structure, but present it in a different way to try and throw you off. There's no need to be thrown off. Remember what I said last time, the first thing, let's make the denominators the same. The only thing I would say here is 3 can't go into 4 and 4 can't go into 3. So we need to think of a number that's in the 3 times table and the 4 times table. The lower the better. The answer is going to be 12. So 2/3, let's change that to 12. So we do 3 times 4. Do the same to the top, we get 8/12. Super. 1/4, okay, again, now it's going to be 4 times 3 gets us to 12. Do the same to the top, we get 3/12. So I'm going to draw on this because guess what, guys? You're allowed to. Do it. It's useful. This is going to be 3/12. Cool. What's left over? Well, 8 plus 3. And again, show you're working out, because if you write something wrong, or if you just simply put an 8 and it looks like a 0, or a 6 and it looks like a 0, you're going to get 0 marks. So show you're working out. That's 11 out of 12. And just like last time, we need to make it equal 12 out of 12, which is of course equivalent to 1 whole. So how many 12s are left over? If I have 11 of them through potatoes and cabbages, only 1/12 is left over to make 12 12s altogether. So 1/12 of the field are carrots. This is just something I'm going to say very quickly. Don't look at the picture and try and just guess. Well, that looks like about 1/10. It's not to scale, okay? Don't do that. That means that it's not represented exactly in the same proportions. So you can't just look at it and guess. That's why they do that. Oh, doesn't this look like one of the most simple questions we've looked at so far? What did I just say when we are working with fractions and we're adding or subtracting them? What do we need to make sure is the same? That's your only hint. Pause the video, have a go. I'll tell you how to do it afterwards. What goes in that gap? I'm going to start by telling you the most common answer. The most common answer is 3/3. The most common mistake, rather. That's because 3 plus 3 is 6. 2 plus 3 is 5. No, don't do it. Let's change this 2/3. We need to change it, and like I said, we're going to make all the denominators the same. So we're going to pick 6, 6, 6. How do I go from 3 to 6? I multiply by 2. Do the same to the top. 2 times 2 is 4. Now it's the easiest question in the world. This is a year 3 question. Okay, I've worked with year 3 children where we add fractions with the same denominator. Genuinely a year 3 question now. 4 plus what is 5? It's 1. 4 6 plus 1 6 is 5 6. 4 chairs plus 1 chair is 5 chairs. The denominators don't change when we add because they're the kind of unit that we're using. We're counting in 6. 4 plus 1 is 5. Simple as that. I've got a couple of questions left that do actually get really quite tricky now. So this one and the next one's quite hard. There's a lot to go through, and these are 2-mark questions. Okay, so at least 2 things to do. I'm going to read it to you. Jack buys 1.5 kilograms of potatoes and half a kilogram of carrots. How much change does he get from £5? So just like all the other problem solving question videos that we've done so far, we are kind of morphing now across strands. This isn't just fractions. This is fractions with weight, with money. Okay, so measurement, money, fractions. Have a go at it. I'll go through after exactly how to answer it. So this one, although it's 2 marks, we're going to have to do more than 2 things. So firstly, let's work out how much the potatoes cost. 1.5 kilograms. Well, per kilogram, it's £1.50. So we know it's going to be £1.50 plus another half a kilogram. But what's half of £1.50? Well, we can do £1.50 divided by 2 using bust-up method. We want to be really sure. 2's into 15 goes 7 times with 1 left over. 2's into 10 go 5. This is 0.75 pounds. In other words, 75 pence. So we spent in total £2.25 on potatoes. Well, we didn't. Jack did. Half a kilogram of carrots. We simply have to half the cost per kilogram. So 1 kilogram is 180. Half of that is going to be 90. So we have 90p. Or, as I'd like to write it so it stays in pounds, 0.90 pounds. We're going to add that to the potatoes. We get £2.25. And altogether, Jack spent £3.15 on his veg. £3.15. That's the end of the question, right? Because I've done two things. No! Don't get trapped. 2 marks doesn't also always mean exactly two things. It means at least two things. We've got to do something else. How much change did I get from £5? Again, if you're unsure how to count on, you can simply use the column method and do some double exchanging. So I'm going to use it without decimals for now, just so I don't get confused. Let's exchange here to the tens, and then I'm going to exchange again so I can get some ones. 10 take away 5 is 5, 9 take away 1 is 8, and 4 take away 3 is 1. We get £1.85 change. Notice I put my decimal back in at the end to avoid any confusion. Well done if you managed to get that. Again, if you're finding it tricky finding change from £5, but you can do the fractions, you have to keep your eyes peeled, aren't you, for when we do a money video. Next one, the length of an Earth day. This is really convoluted, okay? Really convoluted, lots of steps. The length of a day on Earth is 24 hours. Most of you know that. The length of a day on Mercury is 58 2/3 times the length of a day on Earth. What is the length of a day on Mercury in hours? Now, a day, just so you know, is how long it takes a planet to spin on this axis. Mercury takes forever to do that. The Earth takes 24 hours to spin. That's how we get a day and night. Mercury takes forever. So the way to do this, guys, I'm going to help you out before you start, is to split this up. So you're going to have to do 24 times 58 2/3. The only thing I'll say is do 2 steps. Split it up. Do 24 times 58, 24 times 2/3. See if you can get to an answer, and what must you do at the end. Have a go. Okay, so how do we do this? Well, we're going to use long multiplication for the first one. 24 times 58 would give us 58 times more. So we're going to do times 8 here, and we're going to do times 50. Let's do times 8. If you, by the way, if you struggle with this, Hayden's done a really cool video on how to answer these questions in arithmetic style. 4 times 8 is 32. 8 times 2 is 16, plus the 3 is 19, 192. Times by 50, we must put the placeholder in, so now I can just times by 5. 5 times 4 is 20. 5 times 2 is 10, plus the 2 is 12. That's 2, 9, 3, and 1. So 1392, let's just write that out again so I don't get confused. That is how many hours are 58 times. Then we have the small matter of doing 2/3 times 24. Again, Hayden's talked about this on the other video. Go and watch it. It's really useful. Times is the same as just saying of. These are the same thing. So 2/3 of 24. Divide 24 by 3 is 8. Times by 2 is 16. If you weren't sure how to do fraction of an amount, again, go and watch our other videos. We talk through how to do that. So we have 16 hours is the 2/3 bit. So then I've got 1,392. I've got 16. We have to add them up. So we're going to have 8 in the ones. We're going to have 10 in the tens, so exchange over. 4 in the hundreds. 1,408 hours. Whoa! Tricky fraction question there. But hopefully you can see, actually, I just have to break it down into small pieces, which is often the case with these hard ones. And each individual step, well, do I know how to do long multiplication? If not, go and learn how to do it. If you do, super. Do I know how to do fraction of amount? If not, go and learn how to do it. If you do, super. Then you've just got to add. So there's 3 steps to this, but you can do everything in here. And if you can't, you know what to go and practice. Guys, before I go on to the question that's just for you, can you please like this video? Can you please share it? We put a lot of effort into these, and I hope you really like them. Let us know down below in the comments if you did and if you found it useful. We love reading them. So here's a question for you to try, and again, down in the comments, let us know if you get the right answer. I'm trying to trick you. Do you remember what we talked about in this lesson? If you do, you can tell us down below. See you next time.